Welcome back to another M&S tutoring video, and in this video we're going to be learning about charged atoms, also known as ions. Every single atom has an overall charge, whether it's neutral, negative, or positive. A positive charge or a negative charge makes the atom an ion. When an atom gains electrons, it gets a negative charge, but when an atom loses any electrons, it gets a positive charge. To give an atom a charge, the amount of protons and electrons have to be uneven. Say, for example, you have an atom of oxygen, and this atom of oxygen has, let's say, it has 8 protons and 8 electrons, right? It's just a regular oxygen atom, right? Since the amount of protons and the amount of electrons are the same, this oxygen atom has an overall charge of 0, right? It has a neutral charge. But if this oxygen atom had a charge of, let's say, 6 protons and 8 electrons, then the charge of this would be, in this case, it would be -2, because it has more electrons than it does have protons, right? And same thing if it was the opposite. If it had 8 protons and if it had 6 electrons, the charge of this oxygen atom would now be +2, right? And you can think of that as protons as positives and electrons as negatives. So if you have 8 positives, all you have to do is 8 minus 6 to get your charge. And in this case, you have to do 6 minus 8 to get your charge, right? Now, let's focus on anions and cations. Cations are basically ions with a positive charge, and anions are ions with a negative charge. So, say for example, you have another oxygen atom, and this oxygen atom has an atomic mass of 14, and the atomic number is 7, right? The charge is -2, or 2 minus. How would you draw it as a Bohr-Rutherford? Well, to draw it as a Bohr-Rutherford diagram, all you'd have to do is you'd have to draw the oxygen actually as a Bohr-Rutherford. So the normal oxygen as a Bohr-Rutherford would be 8 protons and 8 neutrons. In the first valence shell, in the first electron shell, you'd have 2 electrons, and in the second electron shell, it would be continued with 6 electrons, right? To show that this oxygen atom really has a charge, you have to put brackets around this oxygen atom, and you have to write an overall charge on top of it. You have to write 2 minus, right? If the amount of oxygens is decreased. Well, how do you know which elements have a charge? Well, if you look at it, any element that is close to completing an electron shell, the outermost electron shell, will usually tend to gain electrons and get a negative charge. But elements with, say, 1 or 2 just over the minimum valence electron shells will usually lose their outer electrons and gain a positive charge. So let's take boron into consideration. So boron has a atomic number of 5, right? So that means boron's Bohr-Rutherford diagram, or sorry, let's just do the Lewis dot diagram, would look something like this. So if you have the Lewis dot diagram, it would look like this. So you'd have B, which is the element name, like shortened, and you'd have 3 valence electrons, right? Since there is not 4 or more, this element is more likely to gain electrons, to lose its electrons rather than gain it, because gaining it would take a lot more electrons to fulfill the outer shell, right? To gain, you'd need 1, 2, I'll do it in a different color so you can help visualize. If boron wanted to gain electrons to complete its outer shell, it would have to gain how many? It would have to gain 1, 2, 3, 4, and 5, right, to complete an outer shell. So that is why the charge of boron is positive, because it's willing to lose its 3 electrons, because that's how it will fulfill its outer shell. So the same thing, if you want to make an ion Lewis dot diagram with a charge, all you have to do is you have to make the element name inside. Say you have magnesium, right? In this case, what you have to do is you have to look at the outermost valence electrons in magnesium. So magnesium has an atomic number of 12. So the valence shell should look like 2 in the first shell and 8 in the second shell, right? And it would be followed by 2 in the last shell. Again, for magnesium, it is a lot easier to lose 2 electrons than it is to gain 6 electrons. So magnesium's outer shell would look like this. It would look like 2 plus, right? Because since the original shell has 0 electrons, you need to add 2 more. And the same thing for oxygen. Oxygen's would look like this. If you have O and it's surrounded by brackets, oxygen's outermost, it'd be a lot easier to gain 2. So if you have 1, 2, 3, 4, 5, 6, 7, 8, but instead over here we have to write 2 minus, right? Because it's gaining rather than losing 2 of the electrons like magnesium did. So that is how you identify charged atoms and know whether they will be gaining or losing electrons. Just the main idea is to complete the full electron shell when you're looking at charged atoms and ions. So that's the end of the video, guys. If you have any comments or concerns, please feel free to leave it down in the comment section below. Other than that, thanks for watching, guys.